Now, imagine that we want to talk about one of the first monitors that this graphic card used to work with. And I would tell you that instead of this display that I'm showing you, that monitor could show 2000 characters on itself. Or in other words, it had 25 character rows, and in each character row, it was able to save 80 characters. Obviously, 25 times 80 is equal to 2000. If you imagine the tablet as the display of that monitor, we could just say the scale would be something like this. If I zoom in, if this is 6 characters, you could imagine, or 2 character rows, you could imagine that we would have 25 character rows, and in each character row, if right now we have only 3 characters shown, then we would have 80, meaning if this was the position 0, this would have been the position 79. So let us zoom back, and well, even now you would understand why we would need a character box bigger than the character, so it would have the spacing between the 2 character rows. So let me zoom out again and explain that obviously if we have this many character rows and these many characters, how many memory cells would we need in the refresh memory of our graphic card? And obviously we explained about the refresh memory, and before we said for every memory cell you would need, for every character you would need one memory cell in the refresh memory, and we explained every memory cell would give us actually the position of that character, and therefore that would address a ROM that would give us the character map, which would be 8 bytes long. So your first guess would be that we would need 2000 memory cells or 2000 bytes, but in fact it's twice that. It is the requirement or the minimum of the refresh memory to have a display or display 2000 characters on a monitor is 4000 bytes. In fact, the memory in our graphic card, in this first graphic card, is 4K, even though 4K is actually bigger than 4000, since 4K is 4 times 1024. So let's analyze why would we need twice the 2000? Why would we need 2 memory cells for each character? Just imagine that at first that we designed, or the designers of this graphic card intended to be able to work with other types of monitors, with some monitors that could have shown with more than one color. In here we are saying that everything would be shown either with black or green, and the concept of background and foreground colors, and how it gives us this illusion of having drawing characters on the display by I guess changing the background and foreground color. Let's say you wanted to create a graphic card. Now I explained why I use the word illusion in the next lectures, how the monitors would work. Right now maybe it wouldn't make that much sense. So imagine that the designers of this graphic card wanted to make that in a way that it could work with other types of monitors that could show different colors. For each character, they would have more colors. So obviously they would say, we know that every color could be shown or could be created with the 3 basic colors, which are known as RGB, or red, green, blue. Actually, let me show it to you on this tablet. If I press the color in here, you would see that I could choose any color, or I could choose another tab, and by changing the values of R, G, and B, I could create any color from being completely black, which is 3 zeros for all of them, to be the amount of 255 or FF in hex, I guess, and having the color of white. And changing any one of them, I could create any other color. As an example, if I give red and blue, I would have pink, or any other color that this is. I'm actually not good with colors. Or if we have red and green, obviously we would have yellow, and so on. So let me actually choose white. So we would say we would want to assign one memory cell for the character, for the position of the character in the refresh memory that we talked about, and one memory cell that would specify the background and foreground color of the character box and the character. What it means is, just imagine in our refresh memory that we have written 0x41 in the first memory cell, which therefore specifies that the first character that should be shown in the first position, in the top left position, should be A. Now imagine in the next memory cell, instead of having the ASCII code for the second character, we would have another byte which would represent the color of the background color and foreground color related to this character.